and welcome to Physics at Home. My name is Dr. Ghanshyam Tejani. Let's start. Class 11, chapter number 2, Units and Measurement. The similar content is similar in NEET and JEE, and that is mentioned under unit number 1. And this is session number 6. Session number 1 to 6 are detailed understanding of the full chapter. And here in the session number 6, we will be having a full chapter. We can call it revision or a full chapter in one go. Here major focus will be on various exemplar and practice problems from the NEET and JEE. So ultimate we can call a crash course for that. Let's see. So first, that is a dimensional analysis I just picked. Now in this entire book of 11th standard and 12th standard, we will be following SI unit. We will be following SI units, right? That is the international standards we will be following. The next important term for this chapter, that was a physical quantity. So physical quantity is a product of a numerical value and its unit. Say for example, if I just want to measure distance between two points, say for example A and B, so I can take a scale and I can measure it. Say for example, the distance is 30 millimeter. So here 30 is referring numerical value and millimeter, that is referring to its unit. So every physical quantity, it is having numerical values. Say for example mass. So if I is having 10 kilogram mass with me, so 10, that is a numerical value, and kilogram, that is a unit. Say for example temperature, if you go with temperature, say for example temperature is now 40 degrees centigrade. 40 is a numerical value and that is unit. Great. So full video is also available. You may look out that video if you really wanted to have a deeper understanding for that. Now, as title highlighted here, dimensional analysis. So dimensions are power raised on fundamental units. What is fundamental units? That was already explained previously. I think you should watch that one. So fundamental units, we are having a 7 different fundamental units, basic units, like to measure a mass, that is in the kilogram. So we have in terms of m. If you wanted to have measure a length, so we can write length similar. If you want to measure time, so we have s second, that is in terms of t for time, right? And also we have for the temperature we have Kelvin, like we have 7 fundamental units plus 2 units, right? For the radian, that is a theta, and star radian, that is theta for the 3D object. And by combination of this and the combination of this, we can derive different units, right? So it is says that it is a power raised on fundamental units. For example, m is equal to 1 power, L is equal to 2 power, T is equal to 3. So fundamental unit mass, that means m is power 1, so it is having 1 kilogram. L power 2, so fundamental unit is distance in terms of meter, so it become meter square. And the T is used for T, it is used for time, so it gives second power 3. So this is the method by using square bracket, and on the fundamental units we can show it, right? See, majorly we use first 3 fundamental units only out of total 7. Majorly we go with that. Next is principle of homogeneity of dimensions, right? These are different rules are mentioned for the homogeneity of the dimensions, right? So what it mentioned, every physical equation should have dimensionally balanced. That means left hand side must be is equal to right hand side. So what's new with this? We already studied this, yes or no? But here it is a dimensions of this. Means about talking about this term MLT. We are talking about T. So that must be dimension. Suppose MLT. Suppose M0, L1, T2. So opposite also M must be 0, L must be 1, T must be 2. That dimensionally it has to be balanced. And dimensions of each term. Suppose there is an equation is given A plus B minus C, right, is equal to D. So if it is connected with this multiplication, subtraction or division, right, not division, right, addition, subtraction, if it is there, then each of the term dimension of A must be is equal to dimension of B. Dimension of B must be is equal to dimension of C. That means individual all of this dimension must be equal. That we need to remember. That we need to apply. Then what next? An identical physical quantity can only be added or subtracted. What did it say? If it is 5 second plus 10 second, if you want to add, yes, you can. So total become 15 second. But if I want to add 5 second plus 10 hour, directly it is not possible to add. We need to convert this 10 hour into second. How? 10 hour into minute, 60 into second, 60. So ultimately we'll have some solution 36000 and plus 5. So that become answer, right? So for the addition and subtraction, physical quantity dimension must be similar. Then what next? Two physical quantities of different dimensions can't be added or subtracted. 5 second plus 10 kilogram. There is no sense to add 5 kilogram plus 10 kilogram because 5 second plus 10 kilogram that become impossible case we cannot add. So it is a nature, we know that, right? We know that. The rule, they are coming from nature. And this is very important. The formula containing trigonometry, that means sine theta, cos theta, tan theta, whatever, that is always dimensionless. Because for the theta angle, dimensions are not given. Dimensions are given only for 7 fundamental units. Only 7 fundamental units are having dimensions, other are not having. The next is exponential function e power x. For the exponential function also, there is no dimension. Dimension is 0. These are the dimensionless functions. And it is applicable to log. If it is under log, that means that become also dimensionless. And this cannot be derived. This cannot be derived. So let's solve a few examples on dimensional analysis. The first question, if pressure P is given by P is equal to A minus L power 2 divided by Bt, where L is length, that means length, we know that length it is measured in terms of L, and it is power 1. If it is nothing is mentioned, that means L power 1 or L we can write. T is time, so we can have T that is in terms of T, and A and B are constant. A and B are constant. Find the dimensional formula of B. We need to find out dimension formula of B. Rules. Remember the rules. Left hand side dimension must be is equal to right hand side dimension. That means dimension of P must be is equal to total dimension of this. There is a second term in terms of individual terms, means A and L. If we talk having a connection plus or minus, that means dimension of A must be is equal to dimension of L. Do we know dimension of L? Yes, it is L. That means L square. That means L power 2. So simply A square, sorry, A is equal to L power 2. That means A become L power 2. Dimension of A, that we got answer. Great. So now P, dimension of P, that is equal to A minus L power. The dimension we already have for this. Now we need dimension for B. So we can take B on the opposite side, P on the opposite side here. So it become P, T, then next, we have dimension of A by minus L power 2. Yes, we already got it. So that is L square, because dimension of A must be equal to dimension of L. It is having L, so L power 2. T, we have T power 1. We don't have for the pressure. So what is pressure? Pressure is equal to force. What is pressure? What is pressure? Force by area. Pressure is equal to force divided by area. Force we measure in terms of Newton. Area we measure in terms of L, length squared power 2 meter square. And what is Newton? Newton is equal to kilogram meter per second square. Newton is equal to force is equal to mass into acceleration. That is a Newton. Mass is kilogram. Acceleration, that is meter per second square. If you don't remember directly Newton, right? So alternately you can find by using this formula. Otherwise you should remember, right? Newton is a great person. Sir Newton, we should remember him. Definitely. So for the kilogram, we know mass m power 1. For m, L power 1, S, we need to put this upper side. So S T power minus area is equal to L power. Right? So find pressure is equal to m power 1, the similar term, divided by L power 2. So that become L power minus 1. So pressure, now we have solution. Now so we have all B is equal to L P by T power 2. Let's put the value of, let's move it. B m L power minus 1, L power minus at L power minus 1, T power minus 1, T become 1, and then final solution become like that. So T and T, 1 T is cancelled. Then it moves up direction. So M become minus 1, 2, minus plus 1. So it become 3 and T power 1. When T is moved upward side, so it become 1. Great. Very simple example, I think it is. Let's have another one. If pressure P is given by P is equal to equation A square B E. Remember E, dimensionless. It is not having any dimension. No dimension. Fine. So pressure P, X is distance. X is distance, means measure in meter. Dimension is L. Good. A and B are constant. Find the dimension formula for B. Here also we need to find out B. So what rule says that left hand side dimension must be equal to right hand side dimension, and E power minus A of X, it is not having any dimension. Simply AX is a dimensionless. So A, find X dimension L power 1 is equal to dimensionless parameter. Just put opposite side. A is equal to L power minus 1. Wow. A, now we got A. So your power X has no dimension. A of X, simply A is equal to that solution. See, ultimately this E power A of minus X, it is not having any dimension. So P of the dimension, it must be is equal to A square by 2. Let's change the color. So dimension of only A square by P, that must be is equal to dimension of P. Yes. Take P, B, just B opposite side and P in the downside. A square by P, that for the pressure we already have solution. Let's put this. What about A square? What about A square? What about A square? We got it. A is equal to L power minus 1. L power minus 1. If solution is available, nothing to worry. So AX is equal to L power minus 1. Put this value. AX square L power minus 2. And from the P, put here the values. So M become minus 1. L minus 2. Minus plus 1 become minus 1. And T become plus 2. Plus 2. Plus 2. That's great. So question number 3, it is find the dimensional formula of gravitational constant. See, in many a case, NEET and JEE, there are possible that equations are not given, and this is equation where we should know its formula. So Newton's law of gravitation says that attraction between two masses, it is given by capital G, that is the gravitational constant, multiplied by mass of first one, say for example earth and our body, right? That is a mass 1, mass 2, and the attraction between these two, that become F, and that is directly proportional to mass and inversely proportional to distance square. So F is equal to G m1 m2 divided by r square. We need to find value for G, so we can take G on the opposite side, so it becomes G F r on the opposite side, F r square, and G, and that become m1 by m2, right? This is very simple. It is quite simple. Wow. Rule says that left hand side must be equal to right hand side, and the dimensions we required here, F, that is a force, Newton we already did in the previous exercise, kilogram meter per second, so become m l t power minus 2. You may remember this also if you wanted to improve that. R, that become length, so length power 2, mass become kilogram, it gives mass 2 kilogram, double, it is m square. Fine. Put all the values here, m cancel, so that become minus 1, L power 3, L power 3, L2 plus 1, 3, and T power minus 2. So there isn't any change in this direction. Easy, isn't it? Now question number 4, I think you should pause the video and solve this. Why not? Really, I think you should. In a standing wave, the displacement of particle x at a given time t, it is given by, so equation is directly given, this is just a story. Y is equal to y, it is a x of t, xt, a sine bt. See, we got angle, sine, trigonometry, so that become dimensionless. Cos ct, that will also become dimensionless. Where a, b, and c are constant, find the dimensions of b by c. We just need to find b by c. So b, it is under sine and cos, right? And both are powerless. Not powerless, dimensionless. Sorry, sleep of tongue. The angle of sine and cos have no dimension, so bx and bt having empty dimension. So bx is equal to x. So what is the dimension of x? Dimension of x, b multiplied by l is equal to empty. So b is equal to opposite side, then give l power minus 1. So similar it is mentioned here, l power minus 1. Similar for this angle, it is a dimensionless. For the t, c multiplied by dimension of t time, that is a t is equal to empty. So c, dimension of c become t power minus 1. That is mentioned here. Great. Now take ratio b by c. Dimension of b we already have, l power minus 1, t power minus 1. Now we need to compare here. See, remember wavelength, that means it is a distance in terms of l. Velocity, that is a distance divided by time. Distance divided by time, L by t. Sorry, simply you can say L t minus 1. Wavelength, 1 by distance, here 1 by L t minus 1. So we need something 1 by, so we can put here simply 1 by 1 by L. Just move this, so it become L power 1. So it is, you can compare. This t, option number D is a correct. 1 by velocity, wave velocity. So option number D is a correct one. Question number 5, that was asked in JEE 2003. A physical quantities not having the same dimensions are, see, so you should know each and every term's dimensions. It's formulas, right? So from that you can derive. So first it is given. First, let's take option first, torque. See, what is torque? Say for example, let us consider one bar. It is assumed that it is having a straight bar and it is having some kind of lever, and with this lever I just wanted to rotate. Some applying some force at some distance, or you can say radius r, and because of that this rotates. So product of force multiplied by distance, that gives us a torque. That gives us a torque, right? And what is work? Force multiplied by displacement. Say for example, some object, if we have, and some force is applied, and because of that the objects moves, and the shape, there is no change in shape, objects moves, right? So force multiplied by that displacement, that become work. See, if you see the equation in the both the cases, force in Newton, displacement in terms of length. So ultimately, it's a dimension are the same. No calculation is required further, right? Go straight forward. Option number two, because one is wrong. Now momentum. What is momentum? Momentum is equal to mass multiplied by velocity. So momentum is equal to mass multiplied by velocity. Velocity mass is equal to m power 1. Velocity TL power minus 2. We know that. And what is Planck constant, right? See, each and every equation you should remember, otherwise there are higher chances to lose some of the marks. So Planck constant is equal to energy of quantum of electromagnetic radiation, right, divided by its frequency. See, ultimately it is just a energy. It is a one kind of energy divided by frequency, and frequency is equal to 1 by time. So it is energy multiplied by time. It becomes simply energy multiplied by time. It becomes energy multiplied by time. So energy measured in terms of joule, we measure in terms of second, and Planck's constant, that is energy, it is a kilogram meter square by second square. Energy equation you just need to remember, energy and multiply by second. So it become m power 1 kilogram for the distance, L power 2, and S become minus 1 t. Hey, compare. Here, answer number B, it is matching. Yeah, there may be some error, might be there. This might be one. Fine. Now, next part, it is significant figure. See, when we take an experiment, there are possibilities to have some error, right? And therefore, experimental results are never equal to true results, and therefore, we need to take multiple experiments. So here, significant figure, it is useful for special this case. If you are sure that you have 100% true result, then significant figure is not required. But in practical life, if you are calculating apples, say for example 50 apples, so in this case, you can exactly say, yes, I have 50 apples. But if I say 1 kilogram apple I need, in this case, you cannot say it will be 1 kilogram. It can be 1.001 kg. We don't know what is the accuracy of that. And it is very difficult to get exact accuracy. And therefore, significant figures are important. So let's see here how it works. So the significant figures of a given number are those significant or important digit. That means what? The important digit. Say for example, if I say we will meet tomorrow at morning 8:30 a.m. See, I can also say 8:30 and exit 10 second. Does it require to show 10 second? We are not starting any channel, right? Movie, right? Where that will exactly it will start. Even nowadays, movies also they are not starting exactly at the same time. So here in this case, we just need 0.83. That means only we need 3 digits. So this is significant. What exactly accuracy? Up to what accuracy we are going? That is the significant, right? And it shows the precision accuracy. It shows it in terms of precision accuracy. If you want to learn about precision accuracy, we have a video, a full video. I think you should refer to that. Significant figures are having some rules. Rules. What it said? First, it is all non-zero digits are significant. Say, for example, one value is equal to 1, 2, 3, 4, 5. Non-zero, 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 non-zero. Right? So, all are non-zero. That become 5 significant figure. That become 5 significant figure. Very simple. Let's have another example. 2.63212. 2 non-zero, 6 non-zero, 3, 2, all are non-zero, so it become a 6. All are significant. That means if there is no zero is available, all are significant. That we know even, right? That we know. So rule number 1 is very easy. Second is all zeros between two non-zero. That means trapped. Zero is trapped. Say for example, 101, room number 101. If 0 is trapped in between, so 1 is a significant, non-zero, non-zero, it is trapped. That means significant digit is 3. That become also significant. Say for example 1.003. So what? 1 that is significant, 3 is significant, all in between must be significant, so it become 4 significant, 4 significant, right? So this rule is also very simple, right? If it is trapped, then all of should be significant. The next, yeah, this one is important. Trailing zero or ending zeros. That means the zeros which are coming at the last. In this case, what are we going to do? So there are two rules. One is that after decimal, suppose if there are decimal 0.00, something like decimal, right? 1.00, something is there is some decimal point. If it is after decimal and that is and zero, we need to check two conditions. There is a decimal. Yes, there is an ending zero. Yes, so all of these are to be considered significant. These are significant number. Say for example 2.00. 2, yes, it is non-zero, significant. Last 00. So we have to consider three significant number, right? If there is a decimal point, we have to consider significant. One more example, 35200. There is no decimal point. There is no decimal point. There is no decimal point. No. So just remove this. We have only first three significant. So next rule says that without a decimal point, not significant. These are not significant. If there is no decimal point, in this case, we cannot consider. So this rule number 3 is somewhat tricky. It shows that if there is a decimal 2.6700, that means this 00 are also significant. But if I write 26700, then last two zeros are not significant if there is no decimal point, right? So that we need to remember. For all initial zeros are insignificant. All initial zero, if they are zeros are coming at starting position 007, James Bond. But in the mathematics, this zero are now having no value. So James Bond become only 7. There is no 007. Now it becomes 07. So in the significant digits, say for example 0.1.2340. So see, there is a decimal, so last ending 0. Yes, it is a significant, but the first 0, this is not a significant value. So how many significant we have? 5. 1, 2, 3, 4, 5. Right. We have to consider all zeros, initial zeros are insignificant. Initial zeros we have to remove. Whether it is a decimal or non-decimal, it doesn't matter. For all the initial zeros, right, are not significant. We know that. Say for example, if I give you 100 rupees and if I add two more zero ahead of this, it still remain 100. It won't become more, right? If I just add behind, then it become 10,000. But in 10,000 also in significant digit, it is not important. Then power of 10, say for example 6 multiplied by 10 power 5. So 10 power 5 are not significant. 10 power 5 are not significant. Only this 6 digit is only significant. So only 1 become significant number, right? So whenever you see 10 power something, it is not significant. You may directly connect with this, right? Trailing zeros without a decimal point. Say for example, let's say 1 is equal to what become 1 multiplied by 10 power 3. So this 3, there is no decimal. Remove, then it is not, right? Only one significant. That is only one significant. Great. And then universal constant. Say for example, pi. Pi is equal to 22 by 7. You can say 3.14. But. See, when we talk about universal constant, then full value is non. And these significant figures are applicable when there is some doubt. Then there is some uncertainty when you have some error in the result, right? But pi is the exact value. Pi is the exact value where this rule is not applicable. If I say 50 apple is required to purchase, 50 apple is the exact value. There is nothing to worry. And in examination, NEET and JEE, they usually ask this kind of question. So you have difficulty in that. Next is rounding of digits. How to round off this uncertain digit? So rule are very simple. If our digit, let us directly understand by example 2.343, it is having 4 significant. Let us convert this into 3 significant. 3 significant, so we need 3 digit only. 2.3, that is okay, but what about this 4, number 4? What about number 4? For this number, you just need to check the next number. If this next number is less than 5, then keep 4 as it is. There is nothing to change. So this is a rule. It is very simple. This is rule number 2. Say for example 3.567 and current is 4 significant number. We just need to convert this into 3 significant number. So let's convert this. How it works? So we need just 3 digit and become 3.5, but we need to think about this digit. And for that we need to check the next digit. If this digit is greater than 5, so this 6 should become 7. Just simply plus 1 to the last digit. Just make a plus 1 to the last digit. Here everyone know this, right? This one and rule number 2. There is nothing new that everyone know. Talk about something new. So new is here. 3. Number 3 is near. What did you talk about that? 3 points, say for example 3.55 and then 0. We need to convert this into how many significant digits? 3 significant digits. So how? You can say directly that it should be 3.55. Answer may be correct, but the method is wrong because what? First we need to check whether the last digit, this is 0, right? After 0, if there is some digit, say for example 1, 2, 3 up to 9, if there is some number, then this become 3.5 and there is a plus 1, 6, right? Maybe 0.3 point something like that, right? So it become 6. If there is something is present, so it become but if you say that 3.55, it is only like that, you just convert this into 3 significant digit. There is nothing. Only 0, 3.55. And the question arises, oh, there is a difficult time now. So here, After significant, the number is required. We need to check the next number, and if it is odd number, then this become 5 becomes 6. But here it is even number, so 5 remain 5. Let's have one more example. Let's have one more example. 3.55, something like that, and after that it is 0. So we need to, suppose if we need to just convert this into two significant digit, let us just consider two significant digit, right? So here it is 5. We need to talk about this point, 3 point something become. So here we need to check this number. We need to check this number, 5 number. We need to check if this number is even, then it become odd. Sorry, if this number is odd, then it become even, right? Just plus 1, 6. So here 3.5 become 6. Here number is odd. But if in place of 5, if we had 4, if this number was 4, so this 4 number is even, right? This number is even, and in this case, it remain as it is. There isn't any change. For that. That may be tricky. I think I suggest simply that what you do, there is a full video on that with so many examples. I think you should refer to that. And the 4 number multiplication. So in the case of multiplication, say for example 1.1 multiplied by 2.34, whatever answer it is there, it should hold two significant digit. It says that, right, original number with the least significant figure, right? Whatever products are there, this is one number, this is two number. You may have 0.23 also 3, right? So what is the list? Here it is having two significant digit, that is also having two significant digit. So your answer should have two significant digit. So minimum number of significant digits are required in case of multiplication and division. And in case of addition and subtraction, the rule is slightly changed. Say for example 0.11 plus 0.123 plus 0.124. Say for example this becomes 7, 5, 3, 0. So in the case of significant, we have to see the point after decimal. This is the decimal we need to check, and then we need to check list decimal places. How many places here? We have two decimal places. Here it is 3. Here it is 3. So list decimal place 2. We just need 2. So it becomes 0.36. 0.36. Very simple. This is very simple. Let's have question. So question number 6. A body of mass m, mass is given, is moving along x-axis with speed 5 meter per second. The magnitude of its momentum is recorded, and that question was asked in JEE 2008. What is equation of momentum? Is equal to mass multiplied by velocity. Can we put mass multiplied by velocity? Mass is having 3.513 multiplied by what is velocity? 5.0 meter per 5.00 meter per second. So that is having 4 significant digits, and the below number it is having 3 significant. In the product, list the significant number of the original to be taken. So list a significant number, it is here 3. Let's check the first significant number. Here it is having 4. Here again it is having 4. Here it is having 3. And this is having 5. Answer C is correct. No calculation is required, right? You check this. If calculation is required, then only you go for calculation. If it is not required, don't go for that. It is not required here, right? So we are checking solution for that. Mass is equal to this, speed is equal to this, momentum mass multiplied by speed, right? In the rule of multiplication or division, the final result should retain as many significant figures as there are original numbers. So original numbers are having minimum is three significant figures. So last answer should have three significant figures. So answer is C. Answer is C. Now next is error analysis. As I mentioned earlier, every calculated quantity has some error. That means a measured value is never equal to actual value or a true value. And that is true, right? How accurately we measure, it is not possible to measure values exactly. So we have to take iteration, we have to measure multiple times, right? And so from that we can find out absolute error. So actual error minus measured error, and you know that we cannot measure actual values. So average mean value, that is to be taken as a actual value. If experiment is performed, certain experiment is to be performed maybe 10 times. So error has to be reduced and average is to be taken as a original value. So mean value. Then we need a mean absolute error. So delta x is equal to this absolute error, delta x1 plus delta x2 plus delta x3 delta xn by n, and we need ultimately a relative error or a fractional error. So mean absolute error divided by mean value, and if we just need in terms of percentage, we can just multiply by 100%. Examples, large number of examples were solved in the previous videos. I think you should refer that to have more understanding. Now next is order of accuracy or propagation of error. So error in the summation, addition, right, or the difference or subtraction. So when we need to add an error, so in this case x is equal to a plus b, that means a is having some value error, a plus or minus delta a, and b is also having some error, b plus or minus delta b. So addition of x is equal to a plus b is very simple, but differentiation delta x is equal to, again we need to add error, right? If we are measuring two different things and if we wanted to have a final result, so errors are also get added. In case of addition as well as subtraction, in the both the cases error to be added, right? Don't make a mistake in the case of a subtraction where error delta a minus delta b is wrong. It must be delta a plus delta b. So check that. So next is error in the product or multiplication. Here differentiation is required. A multiplied by x, or you can say division by b, that is fine. What should be that? Solution. So differentiation is required here. Delta x by x. Here opposite side is delta a by a, delta b by b. Here it become, for both the cases multiplication division, it become plus. The reason is that we are finding maximum possible error. This refer to maximum possible error, and therefore we need to take total distance of error. That's why it is always a plus. It is always a plus. That's all. Question 7. The error in the measurement of a diameter of a sphere. Let's consider our sphere having some diameter d is 1%. That means error is given. We can take diameter delta d by original d, that is 1%. Fine. The percentage error in the measurement of value, measurement of volume. We need to consider volume here. What is the equation of volume for a sphere? Yeah, you know it. See, you need to remember all of these volumes and areas. So V is equal to 4 pi by 3 r power 3. Here we are measuring diameter, so we need to convert in terms of diameter. 4 pi by 3 d by 2 power 3. If we just need error in the product, so equation become like that. Delta x by x, that we know rule, is equal to delta a by a plus delta b by b. For the product, is multiplication as well as division, the rule is same. There is no change in the rule. So now in this case, v is equal to some constant 4 pi 3d. These are a constant. D power 3, something like that. Right? So it is a power 3. It is a power 3. So it becomes delta v by v, and it is a 3 times, right, d multiplied by d multiplied by d. And this constant value are not covered in this error, so the constant remain as it is. There is no change in terms of it. It does not make any change in the error. So that become delta d by d plus delta d by d plus delta d by d. What become 3d 3d 3d. It is not 3d printer, but it is just a 3d by d. What is 3d by d? 1%. Put this value here, 1%. That is answer is 3%. The answer is 3%. This kind of question can be asked NEET and JEE. Be ready for that. Next time we will see this. Now question number 8, I think you should pause the video and you should solve it. What is mentioned? In an experiment for determining density for a rectangular metal block, a student makes the following measurements. Mass of block m. So mass is measured by a student 39.3 gram, and that student is measuring for some kind of block. Having some LBH, whatever. So length of block, that is x, is something given 5.12 centimeter. Then breadth is given y 2.56 centimeter, and height, I think thickness is given. Okay, thickness is given 0.37 centimeter. Fine. So find the value of density up to appropriate significant figures, starting, right, uncertainty in the value of density. We know the density is equal to mass divided by volume. Density is equal to mass divided by volume. So rho become m is equal to x, y, z. So here m divided by, so division rule is there, x, y, z are in the multiplication. So we have 3 multiplication and 1 division. We have 3 multiplication, 1 division. Good. So what rule says that for the division or product or division, whatever, delta x by x is equal to delta a by a. So it become delta, here it should be a rho, is equal to delta m by m, delta x by x, delta x by x. Okay. Do we have value of error? Yes, it is mentioned here, uncertainty in the measurement mass. So that become 0.1 gram. And in the measurement of x by z, that becomes 0.01. That is also 0.01. 0.01. Do we have original dimension m? Yes, it is given 39.3. Do we have mass? Yes, we have mass 39.3. We have x position 5.12, y position also we have 2.56, and z position 0.37. Oh, great. We have this all the solutions. So now what? Put this all the values here, that become rho, right? And we know that rho is equal to mass by volume, so mass is equal to 39.3 gram, and opposite side you can take all this value, and ultimately you will have solution 2.86 gram. And see, in the option the same solution will be there, but this answer is wrong. Why this answer is wrong? Not because of mass here we put, but here we need to take appropriate significant figures. So in the case we need to take appropriate significant figure. You just see the figures in the case of division having how many values? 1. So ultimate it should be having 1 only. So it becomes 0.3 gram per centimeter cube. Gram per centimeter cube, right? So next, that is a Vernier caliper. Yeah, very excellent topic and favorite in NEET and JEE. So this is Vernier caliper. This is a main scale. It is mostly made up by steel, and this entire part is connected to one unit, right? That become a single unit, and that is main scale. That scale is similar to we use in our day-to-day life. That you can say this distance 0 to 1, right? Centimeter, and that smallest unit that gives us a millimeter. Smallest unit that gives us a millimeter. Fine. Then you can see this a small chotu scale, that is a Vernier scale. That become a Vernier scale. And the combination of these two, we can measure dimensions, but we will see afterward. So this is main scale. This become Vernier scale. Fine. Now this, if you see number ones are known as internal jaw. So in the between this jaw, we need to just hold object, and from this scale we can measure length, width, height, diameter. But if you wanted to measure internal diameter of a cylinder, say for example the glass we have here, and I just want to measure inside diameter d, so we need this external jaw. So object is to be placed here like that, and that external jaws we can measure. And this is the depth road. We just need to, if we want to measure a depth of this glass, so just we need to put this depth, and again dimension will be visible. Here our major focus, it is only in this side, main scale and Vernier scale, and this is the main part. Let's see. So this is a main scale, how it works. In the main scale, this is main scale, this is a Vernier scale, right? And mostly in the forward Vernier scale, main scales, you have to take 9 division, means 1 to 9, and that 9 division Vernier scale generally divide into 1 more less, that means 10 division, right? So each division is having some shorter length for that. So list count is equal to 1 main scale division, 1 main scale division, this division 1 main scale division minus 1 Vernier scale division. So we know that Vernier scale division is smaller compared to main scale division, so we can find list count. But we don't know exact value, so what we do? We take main scale division like that, and let us n, and that means within a certain similar length, Vernier scale having n number of teeth, or you can say division, and within this same length, m number of divisions are on the main scale that we need to have. So we can put here, and then we can take just VDS. It is not VDS, VSD. Vernier scale division is equal to m by n, main scale division. So ultimate list count become main scale division 1 minus m by n. That red color you need to remember. This one will be helpful to you. See, Vernier caliper, we have a full session with plenty of example. Right, I think you should refer that also to understand the topic a deeper way. Then how to read this? So we need to just read main scale. So just before this zero, so that become 1. Here 1, not 1, it is 1.1. 1 plus 1, that become 1.1 centimeter, and then you need to find the combination, means a division which coincide. So if you check this division which is coinciding, So the six number division is matching. So equation is like that. A Vernier reading is equal to main scale division plus Vernier scale reading VSR. How to find VSR? VSR is equal to list count multiplied by coinciding Vernier division. The division which match with the opposite one. So six number is matching here. So list count, whatever list count, say for example 0.1, let us assume multiply by 6. So Vernier division becomes 0.6 for example, right? So that you need to remember. Now there are possibilities of error in the Vernier. Right? Vernier gets older like us, and it may report some error. So at a closing position, we need to check error. At a closing position, we need to check error. And equation of error is again list count multiplied by, right? It's a coinciding division, right? See, this if this 0 is towards left of main scale 0, so that is a positive error. And if this 0 it is right of this main scale 0, so it become negative, and it become negative. So finally, if you wanted to have a correct reading, so whatever we read from the Vernier, just minus 0 error. If it is negative, automatically become positive. If it is positive error, automatically it will be deducted. So no need to change anything. So let's solve. Question number 9. A Vernier caliper has 1 millimeter mark on main scale. What is the meaning of that 1 millimeter mark on a main scale? So that is main scale reading. That is main scale reading. It has 20 equal divisions on Vernier scale which match with 16 main scale division. So the 20, 20, 20, it is referring to small n number of mark in the equal distance, and here 16 number of marks with the equal distance on a main scale. So it becomes m. For the Vernier calipers, list count is solutions are given, and options are given, not solutions. JEE 2010, this question was asked. List count is equal to main scale division 1 minus m divided by n. Main scale division is given 1 millimeter. Do not forget to put unit. M is equal to not 2 but it is 20 and is 16. Put this value here. 16 by 20 and MSD is 1. So 4 by 20. Answer is 0.02. Answer is 0.02. It is given, yes. Also check unit, right? Also check unit, otherwise you may have wrong answer. Question number 10. I think you should pause the video and you should solve this. What is given? In an experiment, the angles are required to be measured. Now this is to measure angle. The Vernier calipers are also used to measure angle. Yes, special verniers are available, like they are called vernier protectors. Are required to be measured using instrument. Then it is given 29 divisions of the main scale, so that become m, exactly coincide with 30 division of Vernier scale, that we know n. If the smallest division of the main scale, that means what? It is given main scale reading. Then the least count of the instrument is 1 degree, half degree, 1 minute, half minute. JEE 2019, the question was asked. So we know that least count is equal to main scale division 1 minus m. So m is equal to 29. This all things are given, right? The equation is same. There is nothing to change. And this is the caliper. We are talking about Vernier caliper, which measures, which is used to measure angle. Put this all values. Main scale division 0.5 degree, m is 29, 30, and then become finally you can get this. Now let's check solutions. It is given 1 degree, half degree, 1 minute, half. It is given in minute. degree. It is not 1 degree, 0.5 by 30. So it is not 1 degree. It is not half degree. So we need to convert this into a minute, and we know that 1 minute, can we convert? Yes, 1 degree is equal to 60 minutes, and 1 minute is equal to 60 second. That we have to remember. Remember this. So put this here. Answer is 1 minute. Answer is 1 minute. C is the correct answer. C is the correct answer. So this kind of questions, right, you find in the JEE as well as NEET examination. These are there. Be ready for that. The next is a screw gauge. It is also known as micrometer. In case of Vernier calipers, the least count was around 0.01 centimeter. In the case of screw gauge, it adds one more zero. So let us understand first what is a screw gauge. So screw gauge, it is having, this is a screw, this is a screw, it is also known as a spindle, and it is having thread. It is having thread. Then in between spindle and anvil, that is also known as stud, that work piece that we need to measure. The thing we need to measure, we need to just put in between, right? So we can get its measurement. So end portion is known as anvil or stud. They are having multiple names. You need to remember all of them. Then this frame is known as U frame. This frame is the entire frame is known as U frame. And now if you see here, you can see scale, which is referring millimeter dimension. That is the main scale. That is the main scale. That main scale is also known as sleeve or pitch scale. So you need to remember multiple names for the main scale. It is main scale, pitch scale, or a sleeve, which shows a main dimension. Then you can see here there is some cylindrical portion. This one, which is having some kind of number 0.45 like that. So that is a thimble scale. The more popular name for this, it is a circular scale. That is also known as head scale or a vernier scale. But circular scale is more popular, but you should remember all of this name. The question can have with a different name. And last one is a ratchet, right? A ratchet. Ratchet is just required to just having a protection against over tightening of this screw. Right. So these are different parts. If you want to understand this screw gauge, micrometer, I think you should refer to the full video. I have a full video of on a screw gauge micrometer with plenty of examples. I think you should refer to that. So how to measure? If you see, this is a main scale. The last division, right, which is visible, we just need to see this first. So that become main scale reading. That become main scale reading. So it is 5 plus 1, 6, 7, 8. So 8 mm plus something from the vernier scale reading. We will see how to read a vernier scale. Just wait for a minute. So least count is distance moved by a tip of the screw when turned through one division of a circular scale. See, in this case, this pitch means distance between two consecutive thread. Pitch means distance between two consecutive thread. This pitch, it is always equal to pitch of, or you can say list count of main scale. See, list count of main scale is not equal to list count of total instrument. Remember this question may be this kind of usually asked. So what it's saying, the distance moved by this spindle, or you can say tip of the spindle or tip of the screw, when it is turned through one division. Which one division? This is one division. This one division, right? So from that we can find a list count of this scale. Let's move. So list count is equal to what? Is equal to this distance pitch divided by how many divisions are having this circular scale. So pitch divided by CHD. means circular scale division. Circular scale division. Short names are easy to remember. That's why CSD has written. If you write a full name circular scale division, it takes much more time and we don't have much time during examinations. Always go for short names. So pitch, we know the distance between two consecutive teeth, and we need also lead if you wanted to understand what is lead. So I think you should refer to my video for the lead. For the screw gauge, it is mentioned inside. So lead is linear travel of the screw or nut for one screw revolution. So if we take one full turn 360, what is a movement of the screw? That is a lead. And in the case of screw gauge, the lead and pitch both are equal. Lead and pitch both are equal. But we need to understand what is difference between lead and pitch, because examiner know, and that question they may have some change for that. The next is list count. We already seen pitch divided by number of circular scale. So pitch, whatever it is visible here, minimum distance and total number of divisions. Okay, great. Also list count we can refer to LC, circular scale division, CSD. It is good to refer like that. Then how to read? Like similar to Vernier, we here measure main scale. Whatever the last digit is visible here, that become main scale reading. And combination of this, we need to measure list count multiplied by coinciding circular scale division. The division which match. The division which match. So for example here, we need to see match with a baseline, or you can say reference line, and this is 0, right? So the division which is in contact, that is 0. If it is division is in 5, so take division as a 5. So by using this we can measure. Then of course this machine is also having some error after some use. There are possibilities that this machine have some error. And how to find this error? Suppose if this is the baseline and the 0 of circular scale, if both are coincide, if both are coinciding, that means no error. There is no error. But after certain use, definitely there are some errors possible. So there are two possibilities are there. So this is a base 0, and this is a circular scale 0. If we see circular scale 0, it is below baseline. This is below baseline, so it become positive error. It is in between 0 to 5, it become positive error. So take this error as a positive. And equation is same, list count multiplied by coinciding division when the screw gauge is closed. When the screw gauge is closed. And in case of negative error, if you see the 0 of cylinder circular part which is above, that will become negative error. You can see 0 and 45, it is lying between 0. So negative 0 error, you just put values for that negative, and the correct reading equation is similar. Screw gauge reading minus 0 reading. If error is negative, automatically it become positive. If it is a positive, automatically it become negative. So let's have a question. Question number 11. What did it say? A screw gauge gives the following reading when used to measure the diameter of wire. Take a story, then it's okay. Next is given main scale reading. So this given main scale reading 0, 0. Circular scale reading CSR. Circular scale reading, it is having 50 divisions. So we can say coinciding circular scale reading, right? Or circular scale division, CCD. We use CCD. Given that 1 millimeter on main scale corresponds to 100 divisions, that means one scale, it is a least count of main scale. Least count of main scale, right? So that is a main scale division, and 100 100, it is become circular scale division. So diameter of wire we need to measure. The question was asked JEE 2011. Oh, great. So what here? We know all the equation. You should remember all the equations. Least count is equal to pitch divided by circular scale division, and screw gauge reading is equal to main scale reading plus circular scale reading, and circular scale reading is equal to least count multiplied by coinciding division. Do we have all the values? I think we have. Main scale reading 0 is on the top portion here. Division which coincide, so it becomes CCD 52. Pitch, that is 1 millimeter. Main scale division, that become pitch, and circular scale division, that is 100, that is given. Put this value. So least count we can find by putting this 0.01. Then screw gauge reading is equal to main scale reading. Main scale reading we have 0 millimeter. List count we have here. List count, and the division which match 52. Put this value here. So answer is 0, right, plus 0.01, 52, and reading that is visible, that is 0.52 millimeter. Millimeter it is not given here anywhere, so check this, right? 0.52 given, but it is centimeter, so don't check this. This is wrong answer. Convert this into millimeter, so it become centimeter. 0.052, just add 10, and the solution it is there. A solution it is already there. And this is question number 12. I think you should pause the video and you should solve it. Definitely you should solve it. Let's solve. Question number 12. The pitch and the number of division of on the circular scale for a given screw gauge are 0.05. So that means this is a pitch. And number of division on a circular scale. Number of division on a circular scale. Number of division on a circular scale. So circular scale division. Circular scale division. When the screw gauge is fully tightened, that means close position, and that talking about error. Yes, there is some error in this case. Right. The 0 of circular scale lies 3 division below. 0 is lies 3 division below, that means it's a positive error. Right. And the division which coincide 3 division below, right? So this is coincide division, circular scale division, but this is only for what? This is only to calculate 0 error, right? So do not confuse with this. For the mean line, the reading of the main scale and the circular scale of the thin sheet is 5.5 millimeter. That means it is a main scale reading, and the division which coincide is 48. Options are given here. Let's forget option required. Fine. So here pitch is given 0.5 millimeter. Circular scale division, how many divisions? This body is having 100. Error is positive. Error multiplied by least count multiplied by the division which coincides. So just put 3 here. Main scale reading 5.5, and during that reading 45th division coincides. Great. So least count, put the value of least count here. You will get answer 0.005 millimeter. That is the correct one. Great. For the screw gauge reading, main scale reading plus least count plus multiplied by CCD. We have main scale reading 5.5, which is here. Also, we have least count just calculated 0.005 millimeter, and circular scale division 45th division is having match with this. Put this well, and the answer is 5.74 millimeter. 5.74 millimeter, somewhere here it is mentioned. But wait. It is having some error. So error is equal to what? Actual reading is equal to SGR, screw gauge reading. You need to just deduct error, minus error. Error is already there. List count is a positive error. Multiply by 3. So list count 0.005 multiplied by 3. Answer is 5.725. It is there. 5.725. Answer is that, right? So do not stop here. This is not a correct answer. This one is the correct answer. So thank you for watching Physics Adapter.